Game engines are tools used to build games. They offer you all the features and tools that you will need to make a game, like rendering, graphics, audio, physics, and more. And without them, game development would be a lot harder, since you would have to make all these tools yourself. You've probably heard of a couple game engines like Unity, Godot, or Unreal Engine. These engines are very good for starting out on your first game and building games quickly, but what if we wanted to make our own? The reason as to why you would want to do this is that other engines may not support certain features that your game might need. And the more important reason is that it's just plain fun. And the first thing that you're going to need to make a game engine is to pick a graphics API, such as OpenGL, Vulkan, or DirectX. A graphics API will help us render triangles to the screen. They communicate directly with the GPU, and we'll need them if we want to render anything. You can go with any one of these, but since OpenGL is the easiest and the only one I've had any experience with, I'll be using that. Although you can use whatever you want. But OpenGL doesn't make a window for us, and we'll need a window to display anything, so that's pretty crucial. I'll be using a library called GLFW to display the window, since the library is cross-platform, and you can handle all the window creation inside a window class. This will create a GLFW window and render a black screen, since we haven't rendered anything to the window yet. And to render something, we'll need something to render, and for this we will create an object struct. This struct will hold all the data required to render something to the screen. And to hold all the objects in the scene, we will make an object manager class. This class will have a couple of functions related to adding and removing objects, and it will keep a nice vector of objects. But what if we want to actually render these objects to the screen? For this we will need a renderer, and to build a renderer, we'll first need a solid grasp of shaders. Shaders in OpenGL are pieces of code that run on the GPU, and they tell the GPU how to render an object. Since I'm using OpenGL, all the shaders are going to be written in GLSL, which is a shading language. We will need two shaders, a vertex shader and a fragment shader. A vertex shader will determine the position of vertices, and the fragment shader will actually display them with color, lighting, and shading. A basic vertex shader can look something like this. There are three matrix 4x4s, a projection matrix, a view matrix, and a model matrix. We will need them to accurately display 3D. For this video, I'm going to be building a 2D game engine, but still we will need the three matrices for the Z component, which will offer parallax. We will multiply all these matrices together in the main function to determine the position of the vertex. There is also a vector 2 of texture coordinates and a vector 3 of frag position. These are prefixed with the out keyword, which means that we are sending this information elsewhere. There is also a pose and a text code, which are layouts. These will be set in the C++ code outside the shader. And now let's take a look at the fragment shader. This takes in a vector 2 of texture coordinates and the frag position. There is a sampler 2D of texture. A sampler 2D is just a texture image, and there is also a vector 4 of color. This can be used to determine the final color of the image. We will calculate the texture color and then multiply that by the uniform of color to get the final result on the screen. Since the shaders are now done, we can make a simple shader class to hold the vertex and fragment shaders. The contents of this class are not relevant to this video, although you can find the shader class in the description. And now we should work on the renderer. The constructor of the renderer will set up OpenGL for rendering. It will create vertices and indices. These vertices are for displaying a triangle, and these indices are for displaying two of them in a square shape. Since squares are really just two triangles, it will make a vertex buffer object and a vertex array object. These two objects hold all the vertex data for rendering vertices. And let's make a function for rendering an object. This function will take in a shader, a matrix 4x4 of view, and a matrix 4x4 of projection. This function will calculate a model matrix and will do matrix multiplication to match the position, rotation, and scale of the object. You will have to come up with these matrix multiplication functions yourself, or you can use a math library like GLM, which I'm using, to do this for you. Then it sets all the uniforms within a shader, using functions that are written in the shader class. Then it binds the vertex array object and actually draws it to the screen using GLDrawElements, specifying it as GL triangles. So we can add a function to the object manager to render all objects. But wait a second, where will the view and projection matrices come from? To get these matrices, we can make a camera class. The camera class code is not relevant to this video, but you can check out the basic camera class from LearnOpenGL, which I'm using. And now we can get the view matrix by a function in the camera class, and the projection matrix by using a perspective function, which takes in the camera zoom, the aspect ratio, which is just the screen width divided by the screen height, and the near plane and the far plane. Again, you can make these functions yourself, or use a math library such as GLM. And now we can render some quads with textures. Nice. The basic foundation of the game engine is now done, and you can integrate physics into this engine by either making your own physics engine or by using a pre-existing physics engine like Box2D. You can add a rigid body to the object class and update the position and rotation based on the rigid body. I'm not going to go into details on how to use a physics engine like Box2D. That's for you to figure out. And for this to be a game engine and not a game framework, we will need some UI or an editor. If you're an absolute Chad, you can add the UI to the engine itself, with text rendering, buttons, and other stuff, and use the UI in the engine to make the editor for the engine. This is what Godot did. But if you don't want to do that, then you can use a UI library such as I'mGUI to make your editor. This is what I did in my own engine. And in the editor you should be able to make objects and modify their properties. And for sound and audio you can use OpenAL to add sounds. I'm not going to go into details on how to use it here, of course. This video is not a tutorial on 1,000 different libraries. This is only supposed to be an overview of how to make an engine. But the engine is pretty much done at this point, albeit extremely basic and simple. You can add more features to expand this engine like particle systems, tile maps, and 2D lighting. These features will be pretty simple to implement once you know what you're doing. And I hope this video has been helpful as an insight and overview of game engine development. I truly hope you've learned something and this motivates you to either create a game or an engine. And if you've made it this far in the video, consider subscribing since it helps me out hugely. And as always, see ya.